A bit of background then, and I still think this is useful even though we're involved with the Eurocodes these days. This is BS 5950. This was the introduction to choosing a steel subgrade. Over on the left-hand side, you can see a shopping list of circumstances. And as you go down the table, those become more and more, this is this important word, onerous, more and more onerous circumstances. And over on the right-hand side, depending on the stress level, is it greater than a third of the yield or less than a third of the yield? Then you would end up with a factor. And the lower the factor, well, the more onerous your circumstance was. And then we would compare whatever the calculated results was with a limiting thickness. So this is the next table. We had standard temperatures. So -5 is internal, -15 is external. And these were the maximum thicknesses at those two temperatures for any of these steel grades shown on the left-hand side. And the subgrade, perhaps I should have mentioned that before, but the subgrade is indicated by these two letters after the steel designation. So JR, J0, J2, and so on. And it's those things that we're very interested in specifying. So that's a bit of background, and that will be useful for us when we come on to think about the Eurocode presentation. So the toughness or the impact quality of a steel is measured by the Sharpie test, sometimes called the Sharpie V-notch test. For obvious reasons, you machine a V-shaped notch into a very small sample. There is a pendulum with an anvil on the end that swings from a certain height. It fractures the sample, swings through to a rather reduced height, and the difference in height is, of course, the energy which has been lost. So a Sharpie value is measured in energy terms. It's measured in joules. And this test is undertaken at certain discrete temperatures. Now, the Sharpie value does vary with temperature. So on the bottom axis of this graph is the test temperature. And the vertical axis is the energy absorption or the impact energy measured in joules. And you can see how that falls as the temperature drops and rises as the temperature rises. So most material specifications normally call for a certain minimum energy absorption measured in joules at a certain test temperature. So many of those minimum requirements are 27 joules, which is why that's highlighted. People will know very well about 27 joules, I think, or they will at least be familiar with it. And we are to achieve at least an energy absorption of 27 joules generally at a certain test temperature. And that's a bit more background really to what these subgrades are all about. So here is from one of the product standards, 10,025. So this would be for rolled sections, beams and columns. It lists over on the left-hand side those subgrades for different steel strengths. It tells you the test temperature. So typically 20 degrees, 0 degrees, -20. And it tells you the requirement for the minimum energy absorption. So you can see generally 27 joules. So hopefully now that explains what JR, J0, J2 mean. JR is for room temperature, which is 20 degrees C. J0 is at 0 degrees. J2 is at -20. Okay, so if you can achieve at least 27 joules at a lower and lower temperature, then that's an indicator that you have a tougher steel. Okay, so now we turn to the Eurocode and we will end up in 1993 110 and this table, of which we are looking at merely an extract. So table 2.1, hopefully it's now familiar on the left-hand side, highlighted. We've just got a repeat really of the subgrades, the test temperatures, and the minimum energy absorption measured in joules. And again, you see, broadly speaking, that's 27 joules. Then we see a reference temperature, which we're going to spend some time looking at, but we also see a state of stress, And we remember that 5950 had a couple of states of stress. Was it more than 0.3 of yield, or was it less than 0.3 of yield? Well, here in table 2.1, in fact, there are 3 states of stress. Only 2 are shown on the screen at the moment. Is our state of stress in this limit state, is it 75% of yield, or is it 50% of yield? Or off the table to the right hand side, is it 25% of yield? And really that's what this nomenclature means here. Fy we know is the yield strength. The T stands for thickness, and certainly in the UK we would know that what we would call the design strength, well, that reduces with thickness. We know it's the yield strength up to a thickness of 16 millimeters, and then after 16 millimeters it starts to drop. Well, that's what that means. Fy open bracket T close bracket. It's reflecting the change in design strength as the thickness varies. So we need later on to work out our state of stress and compare it to this design strength.